We've got three other types of formulas we're going to work with today. The next one we're going to call a half angle formula. So essentially, it's if you have the sine of half of really a convenient angle. We're going to talk about what I mean by that in a second. So the sine of u over 2 ends up being equal to plus or minus the square root of 1 minus cosine of u over 2. Now, I want to go, before I go any further, the plus or minus all depends on where u over 2 is. So you need to figure out where it is, what quadrant it's in, and then that's going to help you determine the output of the sine or the cosine. So, the cosine of u over 2, very similar to the sine of u over 2. So it's going to be positive or negative, depending on what quadrant we're in. 1 plus the cosine of u over 2. And then the tangent is going to be tangent of u over 2 is 1 minus the cosine of u over the sine of u, or sine of u over 1 plus the cosine of u. Again, the signs of sine and cosine all kind of depend on where u over 2 is. So, for example, on example 3, 105 degrees, that's in quadrant 2. Now, in quadrant 2, our cosine is negative, and our sine is positive. So, the sines are positive in quadrant 2, the cosines are negative. Now, for the sine of 105, really what we're going to try to do is relate it to an angle that we know how to use. So I'm going to say 105, well that's half of 210 degrees. And 210 degrees is on the unit circle. So we're going to say sine of 210 over 2 is equal to, and again, since we're dealing with positive signs, we don't need to worry about the negative, so I'm just going to say, and just for redundancy, I'm going to say positive square root of 1 minus the cosine of our u value. In this case, our u value is that 210. All that being divided by 2. And then we can just use the unit circle. So the square root of 1 minus on our unit circle, we go to 210 degrees. That's down here. We look at the cosine. That's negative square root of 3 over 2. So we got 1 minus negative square root of 3 over 2, all that divided by 2. Now, folks, we can clean that up a little bit more. We got square root of 1 plus root 3 over 2. And from here, you've got a couple options. I would suggest just breaking these, over 2. I forgot that part. I would suggest kind of breaking these up. I'm going to break it down into the square root of 1 over 2 plus square root of root 3 over 2 over 2. And that way we can break that up a little bit more and make it the square root of 1/2 plus root 3 over 4. Now, those are two separate fractions. We can actually combine them back into 1. So if we make 1/2 into 2 over 4 plus root 3 over 4, we can now make it one single fraction as 2 plus root 3 over 4. Now, this is a bit messy, I realize that. Now, we've got a square root of a fraction. Remember, square roots of fractions, you can take the square root of the numerator, which, in this case, doesn't help us a ton. But we can also take the square root of the denominator. So in this case, it'll be just 2. So after all of that, the exact value of the sine of 105 degrees is the square root of 2, the square root of 2 plus the square root of 3, all that divided by 2. So again, one of the biggest things on this is to identify what the u value is. What's being divided by 2 to get our angle that we're given. So what gives us divided by 2 gives us 105? That's 210. We plug that 210 in and just kind of work through it slowly. The last two things we're going to take a look at, the first one is called product to sum. The last one's going to be called sum to product. So product to sum means you've got a product of trig functions over here, and it's going to break down into some partially intended form of sum, or in this case, a difference. Sums and differences are identical; they're just opposites. So the sine of u plus times the sine of v. If we were to break that down or combine them, or again, if we were to break that down into separate things, it'd be 1/2 times the cosine of u minus v minus the cosine of u plus v. Cosine of u times cosine of v, so again, making sure we're identifying what the angles u and v are, is 1/2 times the cosine of u minus v plus the cosine of u plus v. Sine of u times the cosine of v, so now we're mixing up, or we're integrating sine and cosine, is 1/2 times the sine of u plus v plus the sine of u minus v. And then the cosine of u times the sine of v is 1/2 times the sine of u plus v minus the sine of u minus v. Goodness gracious. Okay. So, example 4, we're asked to rewrite the product cosine of 5x times the sine of 4x as a sum or a difference. So, cosine times sine, essentially we're using this bottom one here. So what I would strongly suggest we do is identify what the u is. In this case, the u is 5x and the v is 4x. So really, whatever the angle is in the first trig function, make that u. In the second trig function, make that v. So if we're following along with this pattern here, we're going to plug in the u's here and the v's in the correct spots there too. So this is going to be equal to 1/2 times, I'll put that in a square bracket, sine of 5x is our u value plus 4x our v value minus the sine of our u value, which is 5x, minus our v value, 4x. Cleaning this up a little bit, we're going to have 1/2 times the sine of 5x plus 4x is 9x minus the sine of 5x minus 4x is just plain old x. And folks, for this, that's really as far as we need to go. You could go a little further, and you could go a little further by distributing the 1/2. So you could say, or it's 1/2 times the sine of 9x minus 1/2 times the sine of x. But honestly, you're usually going to see it finalized in that first form. So again, identifying what u is, identifying what v is, and making sure you're plugging them in. So that's a product to sum where you take the product of two trig functions and multiply them together, but we write it as a sum or a difference, which in this case, we ended up with a difference. The opposite would be, we've got two trig functions and we're going to combine them into one. So we're adding them into one. So we got the sine of u plus the sine of v equals 2 times the sine of u plus v over 2, all that times the cosine of u minus v over 2. Yikes. There's a lot more going on here. We got sine of u minus the sine of v, so in this case subtracting two of them. We got 2 times the cosine of u plus v over 2 times the sine of u minus v over 2. So they're very, very similar. The biggest thing is, this one's the sine of u plus v over 2. This one's got the sine of u minus v over 2. Similarly, the first one has sine or cosine of u minus v over 2, and this one's got cosine of u plus v over 2. For the cosine of u plus the cosine of v, we've got 2 times the cosine of u plus v over 2 times the cosine of u minus v over 2. And finally, the subtraction for cosine of u minus the cosine of v is equal to negative sine of u plus v over 2 times the sine of u minus v over 2. Wow. Okay. Final example. Cosine of 195 plus 105. So what we're going to do, again, identifying our angles, that's u, that's v. So the cosine of 195 degrees plus the cosine of 105 degrees, we're going to follow along with that cosine plus cosine formula and plug in what we know. So we got 2 times the cosine of u plus v, in this case 195, plus 105 divided by 2, we'll clean that up in a second, times the cosine of u minus v, so 195 minus 105 over 2. When we clean those fractions up, well, let's start with cleaning up the numerator. So 195 plus 105 is 300 degrees. And we'll divide that by 2 in a second. The second one, we got cosine of 195 minus 105 is 90 degrees over 2. Cleaning this up just a little bit more, we got 2 times the cosine of 300 divided by 2 is 150 degrees. Cosine of 90 divided by 2 is 45 degrees. And from here, folks, we have this information on our unit circle. So we got 2 times the cosine going to the unit circle of 150. Cosine of 150 is negative square root of 3 over 2. So let's put that in. So we got 2 times negative square root of 3 over 2. And times the cosine of 45 on our unit circle. You might have that one memorized by now. The cosine of 45 is the square root of 2 over 2. So we have the square root of 2 over 2. When we multiply this out, there's a couple different ways we can approach this. You can either just take this as a 2 over 1 and multiply that all out. I'm just going to go ahead and cancel that 2 and that 2 and make it 1 over 1. And this one, root 3 over 1. So now we have 1 over 1, we can kind of just ignore that, times, let's see, going through the numerators, we got 1 times negative 3 times times the square root of 2. That's going to give us negative square root of 6. Our denominators after we reduce is 1 times 2, which just gives us 2. So the exact value of cosine of 195 plus the cosine of 105 is exactly negative square root of 6 over 2.